In this video, I'll show you how to use Web Sketchpad's dynamic algebra tiles. And in the YouTube link below this video, you can go directly to the blog post that contains the Web Sketchpad document that I'm showing here. So here we have our space to play with algebra tiles, and we have various algebra tile tools here in this column. We have a tool to make a 1 tile, an x squared, a y squared, and an xy. So let's actually start putting some tiles here into our sketch. And I'd like to model, how about x plus 2 times x plus 3. So I'm going to start by creating those two expressions, x plus 2 and x plus 3. And let's place x plus 2 here along the top. So I'm going to start by clicking on the X tool. And here I see a preview of what I'm about to get. And notice that this top left point of my tile is glowing. That indicates that I need to place it somewhere. Well, I am going to place that right here at the top, and I'm going to click this point here to attach those 2 points. So now I have X here along this top portion of my screen, and I'm going to then tap on 1, and I'm going to attach this glowing point to the top right corner of my existing X tile. And I want x plus 2, so I'll create one more 1 tile, and I'll attach that right here. So here I have what I refer to in the blog post as a train of tiles, a x, a 1, and a 1, and they're all attached. And the reason I attach them is that if I change the length of x by dragging the slider up and down, all of these tiles remain attached. Now I'd like to create a train that shows x plus 3, and I'll do that here along the vertical portion of this frame. So again, I'll start with an x tile, and this time I'll attach the glowing point right here to this point, and I'll tap. But notice that the tile is, as before, horizontal. I'd like it to be vertical. So I have this point here that sits along what we're calling a flipper. And if I drag this down, notice the tile flips back and forth from horizontal to vertical. So I'll leave it here in a vertical position. Now I'll take this glowing point and attach it to this point of the X tile. And I'll create 2 more 1s, each time attaching them to the tile above. And again, because I've attached everything, we see the tiles remain attached as I change the length of x. Now it's time to think about the rectangle formed by these 2 trains, the x plus 2 and the x plus 3. What does an x plus 2 by an x plus 3 rectangle look like? Well, here I have an x by x squared. So I'm going to fill in this portion of my rectangle with an x squared tile. I'll attach that right here. So there we see x times x is x squared. Now we have x times 1, which is x. So I'll place that here. I'll swing this around. We'll do that again right there. Swing that around. I'm going to need several X tiles here, so I'll double tap the icon to keep it active, the tool active. I'll merge this right there. 1 times x is x. Here's my next tile. I'll place that here. And 1 more right there. And I'll tap on X since I need no more X tiles. Now I need some 1s. So I'll tap or double tap the 1, and I'll start attaching those here, here, there, here, and here. And I am done. I now have this rectangle that's defined by its length and width of x plus 2 times x plus 3. And I see that that product, x plus 2 times x plus 3, is x squared plus 1, 2, 3, 4, 5x plus 6. So I can see that identity visually with these algebra tiles. I can, as I said before, change x so that I can see that it is not dependent on a particular value of x. In particular, here I can show the value of x so that I can see that when x is 9.17, this relationship of the product of x plus 2 times x plus 3 is x squared plus 5x plus 6. And that's true regardless of the value I pick for x. That's a very important benefit of using Web Sketchpad for algebra tiles, since we can emphasize that their length is not important. With physical algebra tiles, we can't change their lengths. I can also choose to hide those flippers that flipped my x's from vertical to horizontal. So now we just see the tiles themselves. There are multiple pages to the sketch. I can move between them using the page controls in the lower right. Here I've put together one more example. We can see two trains, one horizontal with length x plus y, and the other also with length x plus y. I can change both the x and the y lengths to show that the particular lengths don't matter, that this relationship always holds. I can hide the flippers. And we can see that x plus y times x plus y is x squared plus 2xy plus y squared.